All right, let's learn about data structures using C++. What is data structures? Data structure is a way to organize, store, and manage a computer program. And what is computer program? Basically, a collections of data values and their relationship among them. And we can manipulate the data using functions or operations that can be done in data. So underneath data structures, we have data storage. Data storage will organize and store the data. And data storage have a way to manipulate the data using methods. So methods will access and also delete, update, and do whatever, allow us to do whatever to the data. So that's called methods. So let's look at the example right here, adjacent states. And let's first define what exactly is adjacency. Adjacency is when two states shares a boundary. For example, we want to find out state Z, which is state adjacent state. So state Z will be in our requirement to find the solutions for finding state Z. We will need a little bit of conditions, right? So in this case, state Z will not be adjacent to X, state X, but state Z will be adjacent to Y. However, Y will not be adjacent. Y will be adjacent to X, right? So that's our requirement. And then in our input, state X will be our input. And then our expected output will be state Z. So like we said before right here, state Z will not be adjacent to state X, which is input, but state Z will be adjacent to state Y, and state Y will be adjacent to state X. So let's come up with the data structures. Okay, so we can have a list of state X, and then we can use adjacency matrix, right? Matrix will be something similar to math matrix, but we will have a different way to organize the data, the matrix data structures in C++ data structures. So that will be our solutions for this type of problem, right? And what kind of lesson we learn in this example is basically different data structures will lead to a different way of solving the problem, and we will use algorithm to different algorithm will uh, solve the problem in a different efficiency, like speed, right, space and time. And the data structure is used by algorithms to basically manipulate the data and solve the problem, right? So data structure will be organized. Data structure will organize the data, and algorithm will solve the problem. But at the end, data structures decide how to solve a given problem, and that will affect algorithms efficiency. Okay, so it's just like two sides of the coin, right? So algorithms will be on the other side, and data structure will be on the other side. So they complete each other. Okay. So and let's look at the different data structures right here. We have stack, queue, list, trees, priority queue, and graphs. So let's look at the stack first. Stack is basically a container of an object. Sorry, not an object. Containers of objects, and we can insert and remove using less in first out, just like stacking plates, right? And we can never take out any object from the bottom, right? So we can remove object from the last one that we just stack, the recently object that we stack on the top, right? So that's how we remove the objects from the containers. Okay, so how about queue? Queue is basically similar to people lining up for paying their products and at the store or shopping mall. So the first one that come first will be first serve, and uh, and so on. Yeah. So this is similar to queue and stack, but in this case, list is the generic version of queue and stack. So they don't have any a way to remove. They just store the data in linear, right? And in this case, C++ and C can manipulate the list into double linked lists, single linked lists, circular lists, right? So many version of lists, and that will be transformed into queue and stack, right? So and also trees like a hierarchical uh, hierarchical fashion of an objects arrangement, right? Collection of objects arrangement, and they look like trees basically. Family tree, Unix folder and file folder, how they organize their folders. So those are examples for tree data structure. And priority queue is the simple version of the queue, but in this case, priority queue will remove the objects from the queue based on their priority, right? So it can be last name, it can be the number, it can be the ID number, whatever. So when you remove from the queue, the first priority will be the one that removed first instead of first in, first out. Okay, so graphs is like representations of connections and relationship between two objects or more than two objects. And example will be like physical connectivity, logical relationships, right? In this case, airplanes, travel distance, and those type of examples will be graphs. Okay, so algorithms. In this lesson, we learned that algorithms will be the one that use the data structure, the one that solve the problem, but uh, we need the right data structure to solve the problem efficiently, and we can confirm the algorithms work based on two proof techniques: correctness or efficiency, right? So either one of these has to work. If not, then we choose the wrong algorithms or the wrong data structures for the problem. So that's it for our lesson for the data structures. And next, we will learn about algorithms and how we can use in our solving problem solving. There you go.